Hello students, this is the practice questions for the first quiz. We're reviewing those. Remember there's 4 of them, so there's a little image up here that has the first question in it. Everything looks okay to me, so we're going to try this and see how it goes. Alright, the idea is that we have some vectors first and we're going to find components. I'm going to pull a car out of a bog, so we're going to pull in 2 different directions. When we're doing this, what we want to do is draw each vector. Alright, so this is A. It's going to have 1200 newtons as its length, and it's going to have this angle, which we're going to put in here. That's 55 degrees. Right. Now, we're going to do this for A, we're going to do this for B. Right. This is the length, this is the angle. There's going to be a component this way, which is A sub x, and a component this way, which is A sub y. The first part is to find what these are. And we do that with AX is A cosine theta. AX is 1200 newtons cosine 55 degrees. Bring in our calculator. Right, 55 cosine. We're in degree mode, so we get something reasonable. We multiply by 1200, and we get 688. So that's the x part. And in the y part, we're going to do the same sort of thing. AY is, now we're using sine instead of cosine because we have opposite and hypotenuse. We did A sub x, we had adjacent and hypotenuse, that was cosine. So here we do opposite and hypotenuse, and that'll be sine. So A sine theta, AY is going to be 1200 newtons sine 55 degrees. Alright, so 55 sine times 1200. AY is 983 newtons. Alright, I needed to check my math just to make sure I hadn't done anything weird. That's our components for A. Right. We're going to do the same thing for B. So you should pause the video here, try it yourself. We're going to use the minus 42 degrees that's in the problem. So pause. Alright, so we're going to do the same sort of thing. We're going to draw B now. B now goes downwards. And it's going to have 1500 newtons. This is going to be our x component, and it makes this minus 42 degree angle, and there'll be a B sub y. Again, the y part, we're using opposite over hypotenuse, so we'll use sine theta for the y part. And for the x part, we use adjacent and hypotenuse. We'll use the cosine part. So B sub x is B cosine theta. B sub x is 1500 newtons cosine minus 42 degrees. If I do that, right, bringing the calculator back, I do 42 minus cosine. That's positive, nothing wrong with that, times 1500. Right. And so it says it goes over in the x direction, this 1150. that is in 3 sig figs. Right. We'll do b sub y. That's going to be b sine theta. It's going to be 1500 newtons sine minus 42 degrees. And now when we do this, we should get a minus sign because that is going downwards. And so we do 42 negative sine, that's the negative, times 1500, and we get to 3 sig figs 1000. So that's our two components of our vector. When we add the vector, this is the first step. Right? The first step here is just to find the components. Right. So we found B and we find A here. Now what we need to do is add these components. We need to add what AX and AY are to what BX and BY are. So if we're careful, we can go through note BX is 1150 and AX is 688. So we can go through and say our sum, right, CX is going to be AX plus BX. CX will be 688 plus 1150 newtons. Right. And you do it on the calculator. And to 3 sig figs, we'd get 1840. And we'll go ahead and keep 1838 newtons. Now we're going to do the y parts. Right. We have 1000 here in for BY, and we have 983 for AY. So we should have CY is going to be AY plus BY. That's going to be 983 newtons plus, now if you remember, this should have been negative. I've dropped that negative sign. Right? The sine 42 gives us a negative. 1500 sine 42, we get negative 1000. So we want minus 1000 here. Well, that's going to give us 17. So that's not very big. When we draw our picture of the final thing, right, this is step 2, where we add components. When we do step 3, we're going to get something that is almost completely in the x direction and maybe a very small little bit north in the y direction. Right? It's going to be up a little. Right? And the way this is sketched out in our drawing, we have, that right? It's going to be in the, oh, well, one horse is kind of pulling a little bit more north than it is east, right? More in the y direction and in the x direction. But overall, they're both pulling really a lot in the x direction, right? And so they're also pulling in the y direction against each other. So we kind of expect this. This kind of makes sense. And if we were to sketch what these looked like graphically, right? If we sketch what the components look like, so I'm going to do that just here, right? AX and AY are going to look like this. We go over like this, and we go up like this. Right. And now BX is going to go over like this, and then it's going to go down almost like that. Right. And so if we go from the beginning of the very first vector to the end of the very last vector, right, it's going to go and look something like that. You can imagine this vector is just going to be from here to there, and that's very nearly horizontal. Right. So we're going to take these numbers and we're going to find the vector that has those components. We're going to undo taking the components. So pause for a second. Okay, so new sheet of paper, because I'm writing big for the camera thing. All right, draw a second picture. You should have something that goes way over like this. 118.38 newtons. This one will be a very small vector upwards, but we're going to draw it a little bit larger. Right. It's not to scale, but it's close enough. There's going to be an angle in here, theta, and then there should be the length of this vector. This length comes from the fact we have two sides of a right triangle, so we can get the third one. This length is going to come from Pythagorean theorem, from cx squared plus cy squared. So we'll have 1838 newtons squared plus 17 newtons squared. And if we look at that, that's almost going to be exactly that number. Right. But what we're going to do is put that in the calculator. And in fact, when we put that in the calculator, the length of this vector is going to be 1838. And now we'll go and say, oh, it's 3 sig figs. Right. That's one of our answers. Now the other thing we need is the angle that's in here. All right. So shifting that over a little bit, that angle theta, we have the opposite and the adjacent, and tangent theta is opposite over adjacent. Right. So we want to undo that. We want to make this thing say theta equals something of these things. So theta should be inverse tangent opposite over adjacent. And that'll end up being inverse tangent of cy over cx. Right. That's what we're labeling these two things as. And on your calculator, right, you should have a sine, a cosine, a tangent, and a shift button, and an inverse sine, an inverse, it should say sine, cosine, and tangent to the -1 powers. Right. So that's what we're going to do. We're going to calculate this. Right. We're going to say theta equals inverse tan of 17 newtons over 1838 newtons. This is going to be a really small angle, right? This triangle that we made should be really, really narrow, and this is going to be a very small. It's going to be close to 0. And when we calculate, we get about half a degree. Probably to 3 sig figs, we'd say theta is 0.530 degrees. That's going to be the other half of our answer. That's going to be our direction. And that's it. This is step 3, is length and direction. And you can't see that I wrote that up there on step 3. Right. So I'll scan these and make sure that they're uploaded with the video so that you can look back through this. Again, they're on paper, they're a little bit out of order, but not really. They're going left to right the way we're doing it. Right, so this is how these sort of problems work, is that you have a vector problem, you have two vectors, just draw one at a time, find the components of it, and it's all going to be finding a right triangle. Right? We have a right triangle here, and it's going to have a sine component and a cosine component. And you do the same thing here with a sine component. Sorry, sine is by, cosine is bx. Right. So we're going to do another example of that. That's the next next problem that we have. And you'll note the image changed there because I'm learning new software. Yay! Right. We have this plane that's going to fly a trip from Roanoke. I don't know if you've ever flown from Roanoke to somewhere, but you kind of always have to make these weird detours. I once flew to New York and had to go to Atlanta first. And another bunch you have to fly to like Detroit before you get to New York. Just depends on where the planes are coming from and going to. All right. So this is going to be two different flights, two different vectors. And what we're going to do is build a triangle out of each of these and find the components of them. Right? So this airplane first flies from Roanoke to Detroit, and that's got a length of 625 kilometers. Right? And it's this is described as east of north. If you look at the drawing, the angle is around the y-axis. Right? So if we added 90 degrees to it, it would give it to us relative to the x-axis. So we're going to draw, right, this is our vector. It's 625 kilometers north, or northeast. Sorry, yeah, northwest. I've got that drawing backwards. That should be west. Right. If there's ever an error like this, just ask. You kind of get the idea. If you're flying to Detroit, I meant to go west. So I got to fix that. This is our x-axis. So we would do 26 plus 90. Our angle theta should be 116 degrees. Right. So if you wanted to build the triangle here, right, the triangle sits here. Alright, so this is going to be our AX and AY. And this is our positive X direction, and upwards here is our positive Y direction. So for this first vector, we expect A sub X to be negative. It's going in the negative direction. And if we use this, if we use the 116, that works. If we don't do that, then we have to use one of the angles in the triangle. And we have to figure out, this is our 26 degree angle, and this one is 90 minus 26. Right, this other one that's down here. Right, that one's 90 minus 26. I don't like to try to use those because it's very easy to get these mixed up because you always come out with positive angles. If I can find it from the x-axis, that's what I want to do. So we'll find A sub x, that is the length of A cosine theta. A sub x is 625 kilometers, cosine 116 degrees. All right. This is where you put it in the calculator. And after I've done that calculation, I get A sub x is minus 274 kilometers. Again, we're rounding to three significant figures. And in the y direction, we will have A sub y is a sine theta, which is 625 kilometers, sine of 116 degrees. And then when we do that calculation, we just put it in the calculator, and we should get, I get 562 kilometers. So note that each of these things that we're getting match our intuition, right? Is that A sub x goes left, so it should be negative. A sub y goes up, it should be positive. Both of them are less than the length of the vector. right? These are two vectors that have to add up to the third vector. So they have to be smaller. So these are reasonable. Now we need to get B. B is the flight to New York, which actually is kind of a bit south from Detroit. Right, so we want to remember we have these, and we want to get now a new drawing. Right. This is going to be our vector going this way, right, not to scale. This is a longer flight. It's 770 kilometers. It goes just below the x-axis. Right, 14 degrees. And this one we can work with. We can just say that it's a negative 13 degrees because it's below the x-axis. The longer other way around, like this, will be 360 minus 13 degrees, or 347. But I'm just going to work with the minus 13. Right. This will now have components. It goes AX this way, and this way is A sub Y. Right. Let me move that so you can see. Right. So we'll just go through, and these should be B. Right. We should call these vectors B because it's the second vector. All right, so Bx is going to be B cosine theta. Bx is going to be 770 kilometers. Cosine of minus 13 degrees. And then you plug that into your calculator. I'll do it here. All right. Calculator in. We'll do 13 minus sine. Take the cosine of it. 0.9. Yeah, that seems reasonable. Times 770. And we get B sub x is 750 kilometers. Right. There's the number that we got. We're going to do B sub y. B sub y is B sine theta. B sub y is 770 kilometers. Sine of minus 13 degrees. This is where we're going downwards, so we would expect to get a negative number. And when we calculate, right, we're going to go in and do 13 negative sine. That gives us the negative times 770. And we'll get minus 173. So that's our two components, right? We have these two here, and we have these other two that we just calculated. Hopefully they're all on the screen. Right. Yeah. So now we need to find the vector that adds up to the length and direction. Well, if we just flew straight Roanoke to New York, that would be a vector that kind of points up this way. Right. So this should be our C, and it should go over eastward in the x direction, and it should go up. So it should have CY and CX. And we can add our components. We can add the AX and BX. And when we do that, CX equals AX plus BX. CX is going to be minus 274 kilometers plus 750 kilometers. CX will be 476 kilometers. So we now go and we add the y stuff. All right, we have a y thing here and we have a y thing here. All right, so CY is going to be AY plus BY. And so CY will be 562 kilometers minus 173 kilometers. Right, we're adding the negative 173. And so we do 562 minus 173. and we get 389 kilometers. Right. So that's our two components. That's the things that we're going to get length and direction for. So let me move this up, move another sheet downwards a bit. So now, these numbers, right, we want to find this angle theta that's in here, and we want to find the length of this vector. We want to know how far the return path would be. Right? We want to know the direct flight path. So the length of this hypotenuse here, right? We have two sides. We have a squared and b squared. That's going to be c squared. Right? So the length of c is going to be the square root of cx squared plus cy squared. So if you're ever having trouble trying to write this stuff out like this, write the numbers first and then draw the square root. So we'll have 476 kilometers squared plus 389 kilometers squared. Do all that. Now I'm going to pause for a second and calculate that. And when we calculate that out, we're going to have 615 kilometers to 3 sig figs. And that's one of our answers. That's half of it. That's the length part. The other part we need now is the angle. And so for our angle, we need to find, we have opposite and adjacent to the angle. That's going to be tangent theta. And so our angle theta should be inverse tangent cy over cx. It's always going to look like this. Theta is going to be inverse tangent. Our y part is 389 kilometers. And then our x part is 476 kilometers. Again, I'll pull the calculator in. Right, I want to clear it. I'm going to do 389 divided by 476. Get something less than 1. Maybe. Yeah, that seems reasonable. And then we do inverse tangent. Right. If you have a TI 80 something, we can look at that in a second. But we get theta is 39.3 degrees. And that's our other answer. So yeah, if you have a graphing calculator, right, I'm going to swap this out. Right, you got the same sine, cosine, tangent. You can do the same math. I hope this one will work. All right, turns on. All right, so we can do inverse we can just type it in directly. Inverse tangent parentheses 389 divided by 476. Calculate, and I get 39.3 degrees, and I didn't check to see what mode I was in, so I'll go check, and I'm in degree mode, so I'm okay with that. And so we get something that works. Good. Let me stick with that calculator for a while. It looks a little better, I think. All right. So that's how we do number 2. All right. So now would be a good time. Take a moment, take a break, go stretch. It's been, I don't know, a little while. I don't know how long this. It's a 30-minute recording, so I'm going to pause here. Actually, I'm going to stop the recording here. We're going to do a second recording that has problem 3, problem 4 in it. All right. Now, I'm doing this very much longhand, like you would do it on a test. And you can skip certain bits and pieces here where it's kind of obvious what you're trying to do. You know, but you want to put as many details as you can to explain. And if you're not certain what's going on, you want to put more details that you do know about. That's always beneficial to you. But if you're just trying to get it down to get done with the test, that's okay. Right? Just make sure that you tell me what you did. All right, use an equation, and then tell me what you tried to calculate, and then what the answer is. All right. So again, I'm going to stop the video here. We'll come back with part 2. We'll do the other 2 questions.